Alright, this is Dr. Looney. I'm back with part 2 of antiderivatives. So let's have some fun with this, guys. I know you were pretty excited about antiderivative the first time, so this time we're going to go just a little bit deeper and let's get the job done. Okay, so let's look at this particular function now. Alright, slow down, chill out. I know you're looking at this like, you haven't shown us how to do that. I know I haven't. I've only shown you how to do the antiderivative of one term. But look at this one. I got 4 terms in there. But we about to handle this bad boy. All right, so let's get our thinking caps on and let's get it done. All right, so how do you take the antiderivative if we got 4 terms? Well, guess what? We just take it term by term. We can make a little song out of that. Term by term. Yeah. Okay, but anyway. So let's take the antiderivative of the first one. Well, what's the antiderivative of x squared? Well, remember we increase the exponent by 1, so that's x cubed, and divide by the new exponent, so that's x over 3. Not bad. Just got 3 more to go. All right. So we got this minus sign out here, but this exponent is to the first power. So we're going to have x squared over 2, because 1 plus 1 is what? 2. And then we also need to divide by the new exponent. All right, but look at this one. So on this one, we got to be careful because we got to rewrite that as x to the negative 2, right? So when I do that, that's going to give me plus x. What if it's negative 2? If I add 1 to it, I'm going to get negative 1. And then I'm going to have to divide by negative 1. All right. And then that's going to be plus. And remember, this is really 3x to the 0 power. So this is just going to be 3x to the 1. All right. So just had a brief pause there. So let's go ahead and finish this up here. All right, so now that we've taken the antiderivative, let's just go ahead and simplify some of these terms right here. Now, you know we don't want negative exponents, so this x to the negative 1, we actually need to bring the exponent from the numerator to the denominator. So I'm going to go ahead and put the coefficients in front of the variable. So this is 1/3 x minus 1/2 x squared. Plus, and you can really do minus because this is going to be negative 1 over x plus 3x. And don't forget we need to put our plus c on here because when we take the antiderivative, we always need to add the plus c on to the antiderivative. So this is how you do it term by term. And so let's look at another example and see if we can do it term by term for that example as well. This time I'm going to put the square root in there. I'm going to do the square root and the cube root. So let's do x squared minus the cube root of x squared plus 11. And we want to find the antiderivative of that particular one. So I'm going to pause the video and give you the opportunity to try to work this one on your own. And then we'll reconvene and go ahead and get it done. All right, here we go. Okay, so now let's look at this problem right here. We have f prime of x is equal to 2x plus 1. It says find f of x given f of 1 is equal to 2. So remember, when you take the antiderivative, it should get you back to the original function. So I started out saying that when you take the antiderivative of velocity, you should do what? You should get position. Or if you take the antiderivative of acceleration, you should get velocity. So if I want to find out what f of x is, I'm going to have to take the antiderivative of f prime of x. Now, I'm going to introduce this notation because this notation is just another way of saying the antiderivative. So if I want to take the antiderivative of a function f of x with respect to x, then this is the notation. It looks like a little squiggly mark or just a large S. And this is this is how we take the antiderivative, and we call this the indefinite integral. And so we call it the indefinite integral. And so later on you'll see where we say we're going to integrate this function with respect to x, integrate this function with respect to t. So basically this is taking the antiderivative of a function. And so, well, let's just go ahead and do that, because remember I want to find f of x, so I'm going to integrate 2x plus 1 with respect to dx. And so now keep in mind, when we integrate for the indefinite integral, we're going to integrate, we need to make sure we put our plus c at the end, so let's not forget that. But here we're going to get 2x, and remember we take our exponents and we now increase it by 1. So since this is already x to the first power, this just becomes 2x to the second power, and then we need to divide by the new exponent plus 1. And remember, this is technically x to the 0. So this is now going to be x to the first power. And then we need to add our plus c. So potentially we have a candidate for f of x. We know f of x is going to be x squared plus x plus c. But our problem is we need to get rid of this c, because they want us to give the particular solution that when I plug in 1 as my input, my output is going to be 2. So in order to do that, we just need to go ahead and plug in the value of 1. So I know that f of 1, everywhere I see an x, I'm going to plug in 1. So this is going to be 1 squared plus 1 plus c. Well, f of 1 has to be equal to what? 2. So this is now equal to 2. And now I have enough information to solve for c. So that's going to be 1 plus 1 plus c is equal to 2. So that means I have 2 plus c is equal to 2. So if I subtract 2 from both sides, then I know my c is equal to 0. So I found the particular solution. I know that f of x is going to be equal to x squared plus x, and that is my final answer. So I want you to look at this next example and see if you can find the function f given that f of 0 is equal to 7. Alright, so let's go ahead and finish this one. We need to find f of x. I've given you the derivative, so since I want to find f of x and I have only the derivative and a point on the graph of f of x, because they've given us 0, 7, right? So we need to take the antiderivative. So I'm going to integrate 3x squared plus 11, and I'm going to do that with respect to x. So that integration is going to be 3x to the third power over 3 plus 11x plus c. So I can reduce that. That's going to give me x cubed plus 11 plus c. So this is what my f of x is going to be equal to, and then I'm going to go ahead and plug in everywhere I see an x, I'm going to plug in a 0. So I know that f of 0 is going to be equal to 0 plus 11 plus c, and that has to be equal to 7, because f of 0 is equal to 7. So that gives me what? That gives me 11 plus c is equal to 7. So I'm going to subtract 11 from both sides. So c is actually equal to a -4. So I know that f of x is equal to x cubed plus 11. Oh, so this is, I messed up here. So let's go back here. This is supposed to be 11x. So this is supposed to be a 0, because 0 cubed is 0, and 11 times 0 is 0. So actually my c is just equal to 7. Sorry about that. But so, because you get 0 plus 0 plus c, which is equal to 7. So c is just equal to 7. So the answer is going to be x cubed plus 11x plus 7. And then you can also verify that you do have the right answer, because again, you can always take, you can always plug in 0, right? And you can always plug in 0, and what should come out? You should get 7. And then when you take the derivative of this function, you should get 3x squared plus 11. So let's just go ahead and do that. I'm going to plug in 0, and everywhere I see an x, I'm going to put a 0. So again, this is just going to be f of 0 is equal to 7, because 0 cubed is 0. 11 times 0 is 0 plus 7. So that works. Now let's take the derivative, f prime of x, and that's going to be what? 3x squared plus 11. So this is the verification. So we've learned how to, so far we know how to take the antiderivative, which is another way of doing integration. And right now we're just doing it on the indefinite integral. Later on we will learn the fundamental theorem of calculus to know how to integrate on a definite integral. And now we know how to find the value of c if information is given about the original function. So that is where we're going to end for today. So hopefully the videos are being helpful to you. And if not, I would appreciate any comments. Okay, thank you.